In this video, we're going to talk all about linked lists in Java, how you can create them and use them. We'll also talk about how they compare to array lists, and also when you might want to use an array list over a linked list and vice versa. My name's John, and I do a new Java tutorial video every single week. So if you like this video and would like to see more, please consider subscribing so you don't miss the new video every week. I also have a full Java course available in a link down in the description if you're interested. I think a great place to start would be to just go ahead and create a linked list and an array list right here. Let's just say we wanted to create a list of names, so it'll be a list of strings. If we wanted to do that with a linked list, we would just say a linked list string, because it's a linked list of strings. And then we need to give it a name, so we can just call it names linked list equals new linked list. And if you're using Java 7 or higher, which you should be, you can just use the diamond operator here, so just the less than and greater than symbols, open and close parentheses, and a semicolon. In older versions of Java, you had to specify the type that the list holds here as well, so you would have had to put string here. But now with the newer versions of Java, it can infer that type by the type that you put here, so you can just use this diamond operator now. Of course, we need to add the import for linked list, which is just java.util.linked list. Now let's look at how we would create an array list and compare them. We just say array list string, give it a name, names array list equals new array list. Same diamond operator, open and close parentheses, and a semicolon. And then we just need to import java.util.ArrayList. As you can see clearly, the way you create the two is virtually identical. And even the way we would add things to both of these lists is the same. So if we want to add something to our linked list, we just say names linked list dot add, and then pass in the string we want. So we can add the name John. It's a good name. We can copy paste and add some more. Paul, George, and Ringo. And if we want to add elements to our array list, it's exactly the same. So we can just copy paste that code and change this to the names array list, and we can add things to our array list with the exact same method call, just names ArrayList.add. A big reason these classes are so similar is because they're both part of the Java collections framework, and they both implement the list interface. So what does that mean? Now, what we can do is we can actually nerd out and control click into this linked list class and look at the code of the linked list. And here's where it implements that list interface that I mentioned. And we can hop into this list interface, and if we press Control O in Eclipse, it shows all of the methods that a list has to support. So you can see we have a lot of basic methods in here, like getting its size, checking if it's empty, getting a certain element in it or setting a certain element in it, adding an element to it. So because both the array list and the linked list implement that list interface, they both support those exact same list methods. So if you already know the type of code that you have to use to work with array list, those exact same methods that you've used with array list will work just fine with your linked list. So you might be thinking, hey, John, it looks like these are basically exactly the same. I use them the same way. What's the difference? Who cares whether I use one over the other? The difference between these two classes comes from how they're implemented behind the scenes, and depending on what your specific program actually has to do with these lists that it creates. Using one versus the other could dramatically impact the performance of your program. So let's talk about how these are implemented. Let's start with ArrayList. As you might know, ArrayList actually uses an array as its underlying data structure. And just as a quick refresher, you could create an array of strings in Java like this, like string array names equals new string array, and you have to give it a size. Let's say we gave it size 4. As you may already know, an array in Java is a fixed length. So once I've given this names array a size of 4, this array will always have exactly 4 elements in it. What if you start your list with 4 things in it, and later on you find you want to add more things to it? Well, you can't. You're going to have to make a brand new array that's a bigger size, and then you can add more things to it. But if you had to program that yourself, that would be a whole lot of work, right? So what ArrayList does is it does all of that work behind the scenes, so you never have to know how it's working or that it's even doing that. But notice I didn't even have to give it a size here. I think by default, it gives it a size of 10, an initial capacity of 10. Once it reaches that capacity, it automatically creates a new array of a larger capacity and moves all of those elements into that new larger array. But all of that dynamic resizing can take quite a bit of time and resources. Now let's compare that implementation with how the linked list works behind the scenes. Here's kind of a visual representation of how a linked list works. Full credit to geeksforgeeks.org for this image. Instead of having an array, we just have a bunch of different elements. Each element is called a node, and each element in your list has a pointer, a reference, to the next node. So the linked list class starts with just a pointer to the first element in the list, and after that, each node, each element in the list just has a reference, a pointer sort of, to the next node. So the first one has a reference to the second one has a reference to the third, etc. So it's essentially like a big chain, like a bunch of paper clips attached together. So the linked list itself has just a reference to that first element, and then you follow those pointers down the line to get to whatever element that you need. You can also have what's called a doubly linked list, and that is actually what the linked list class in Java is. It's a doubly linked list. So all that means is that in addition to having a reference to the next node in the list, each node also has a reference to the previous element in the list. And it's not shown in this image, but in the linked list implementation in Java, it also has a pointer to the very last element called the tail. So Java starts with a reference to the beginning of the list and the end of the list, but to get to any element inside the list, it has to follow those pointers to get to whatever element it needs to at any given time. Those differences in the underlying implementation of both of these classes have dramatic impacts on the performance of some very basic things that you can do with your lists. Let's say I just wanted to grab the third element in my list and print it out. So in this case, that would just be George. Well, all I have to do is names linked list dot get, and to get the third element in my list, I would pass in the number 2 because it's zero-based like everything else in programming. So if I wanted to print that out, it would just be system.out.println, and I could run my program, and of course, it prints out George. And of course, because the array list also supports this get method, we can do the exact same thing with our array list. And they both print out George. But when you call this method on each of these two classes, what they have to do behind the scenes is way different. In the array list behind the scenes, it uses an array to store all of the values. And arrays have super fast what's called random access. That means you can tell Java to get any specific element in that list. It doesn't matter which one, and it runs in constant time. That means it doesn't matter which element you ask Java to get, it takes the same amount of time to get it. It takes the same amount of time to get the first element as it does to get the 5,000th element or any element in between. So down here, when I say, hey, array list, give me the object at index 2, it does it immediately. It can go right to that index and grab me that George value and print it out. But how it works in the linked list is way different. In a linked list, Java doesn't start with a reference to all the elements in between. It just starts with a reference to the beginning element and the end element. And if it wants to get any in between, it has to follow these next or previous pointers to get the element that it wants. For example, if you had a list of like 1,000 elements and you wanted to get the 400th element, it can't go directly there. It has to just start at the first element and keep getting the next value over and over and over again until it gets to that 400th element, and then it can finally return it. That operation is way slower for a linked list than it is for an array list. However, where a linked list typically kicks the heck out of an array list is when you need to add or remove elements. Let's say I wanted to do something really simple. Let's say I wanted to put the name Jerry right between John and Paul in my list. Well, I can easily do that with names linked list dot add. Now, to insert a value in a certain spot in your list, you have to pass in the index that you want that value to go in. So because I want it to be second in the list, I'll give it an index of 1. And then I pass the value that I want added, which would be Jerry. And of course, the command in the array list is going to be exactly the same. Now let's compare how that insert has to work in both classes. So in the linked list, if I wanted to insert an element here in between A and B, what Java has to do is just start at the beginning of the list until it gets to the spot where it wants to insert the value. And it just has to change this next reference that A has to B and instead point it to the new node that we're inserting. And it also has to change the previous reference that B has to A and instead point it to the new node that we're creating. And then it takes the next of that new node that it creates, points it to B, and it takes the previous of that new node and points it to A. And that's it. It doesn't have to do anything with the whole rest of the list. All the other links in the chain stay exactly the same. There's nothing else it has to shift around or do. It just impacts that small area of the list, rewires a couple of little things, and it's done. For an array list, that really shakes a lot of things up. So what Java actually has to do is it has to create a whole new array behind the scenes that's large enough to fit all the elements that it needs in it. And it starts out empty, so it might just look kind of something like this. Then it has to copy all of the existing entries into their right spots in this new array. So it'll have John here, Paul here, because we need to leave space to put Jerry, then George, and Ringo. Finally, it takes this new element that it has to add and copies it over into its correct spot in the new array. All that just to insert one value into one spot in the array. Now, if we want to remove this Jerry element from this spot in the list, we would have to take each of the elements after it and shift them over one spot. And of course, if you have thousands or millions of things in your list, that's a lot of work. However, for a linked list, you could just get to that spot in the list, rewire your next and previous references to just skip the thing you want to delete, and you're done. You don't need to shift everything else, they just stay in their same spot in the chain. So because of that, adding and removing things from your list are going to be generally way faster in a linked list than they will be in an array list. Now, with all of that information, where does that leave us? When would I want to use a linked list, and when would I want to use an array list? Now think about what actions are faster in each implementation. So in an array list, getting an element at a certain position is much faster. It's instantaneous. On the other hand, inserting or removing a value is way faster in a linked list than it will be in an array list where it has to shift everything around. So here's what the bottom line is. First of all, if you have a tiny list, it probably doesn't matter which one you choose. Computers are just fast enough nowadays where for very small lists, either of these are going to perform basically the same, and you won't notice any difference. But for very large lists, it can really matter which one you choose. An array list, we have learned, is very good at retrieving specific values, but is worse at adding and removing them. So if the program that you're working on is kind of creating a static list that doesn't change very much and has to spend a lot of its time just retrieving different values from it, if that's the kind of work that your program has to do, then an array list is probably your best bet. On the other hand, if your program never really has a need to dive in and directly retrieve some random element from your list, and your program is instead more focused on having to add things or remove things from especially the beginning or end of your list, then a linked list is going to be able to perform those sorts of actions way faster than an array list. But either way, the methods that you call are going to look the same. The list commands and the methods for both of these classes are going to be the same, but the way they work behind the scenes is what is different about them. So that's what's important to know. Again, please consider subscribing if you got some value from this video so you don't miss the brand new video every week. And be sure to check out all my existing Java tutorials and walkthroughs too. I'm sure you'll get a lot of value from them. So thanks a lot for watching, and I'll see you next time.